Hello Year 12, and welcome to our second video here for our sixth topic. We're looking at bearings and navigation now. In our previous video we looked at right angle trigonometry, and we might use some of those principles in this as well, but we need to talk about navigation, about finding your way across the Earth's surface, and we're going to talk about bearings as the direction that you travel. Right. Now, first of all, we'll talk about true bearings or three-figure bearings. Right, even if it's a two-digit or a one-digit number, we tend to give them as three digits, as you can see here with my 0 here. 0, 0, 0. Always measured, two things to remember here. From north, right, starting at north, moving in a clockwise direction. So here we go. The bearing, or the true bearing, from Sydney to Wagga, right, we start at north, we swing around in a clockwise direction until I'm pointing towards Wagga, right. That is an angle of 249 degrees. So the bearing from Sydney to Wagga, 249 degrees. Be careful though, because sometimes this is expressed a different way, and we say the bearing of Wagga from Sydney. From is usually the key word. That's our starting point. Draw a north arrow at the from location and then rotate around clockwise until you're pointing at the destination. Ready? So from and to, just be careful with that. A back bearing, I don't think this is mentioned in the textbook, but a back bearing is the bearing going the opposite direction. So if I have a bearing from Sydney to Wagga of 249 degrees, the back bearing is the bearing, from Wagga to Sydney, going the opposite way. It's a fairly common exam question, actually. Right, you'll be given something, then you'll be asked to work out the bearing going the opposite direction. Now, the way that you calculate it, seems a bit funny to say this, but you either add or subtract 180 degrees, as appropriate. If you can take 180 degrees away, then do that. If your bearing is less than 180 degrees, so you can't take it away, then you add it on. Okay? So you either add or subtract 180 degrees to get the bearing going in the opposite direction. Now, compass bearings, there'll be an example for that further down. Compass bearings, these things here, I have had plenty of experience with navigation, but have never really stumbled across this application. Apparently, though, it's used in some settings. Well, compass bearings are not always measured from north, and they're certainly not always measured in a clockwise direction. They're measured from the north-south axis, and then we indicate the angle of deviation from the north-south axis towards east or west. So, for example, this bearing from Sydney to Wagga, right? Here's my north-south axis. Now, it's more south than north, right? So it's south, and then I need to work out this angle in here, how far away from south it is. Now, 180 would be straight down, so I take 180 away from 249 and I'll get 69. So this angle in here is 69 degrees, so it's south 69 degrees west, because it's west of south. Yeah. Anyway, here is an example, and we'll have a look at this. We're going to, first of all, do these as true bearings. So, the first one here, the bearing from O to A, start at north, go all the way around. It's not 25 degrees, right? It's 360 minus 25, which is 335 degrees. Okay, so, A over here. A, I'm going to say 335 degrees. That's my true bearing. For B, where's B? Oh, there's B. The true bearing of B from O to B, right? Start at north, go around 90 degrees. So we'll say 090 degrees. C, now that is 53 degrees more than 90, so 143 degrees. Oh, we're going to need a little bit more space here, just a little bit more. And D, right, from north, we go around to 180, and then another 40 is 220 degrees. Right. They are the true bearings from O to A, B, and C. A, B, C, and D. Now for B, the compass bearings. Right. So, the compass bearing from O to A is north. It's on the north side. It's north 25 degrees west. Oops. I should have written A in there first so we know what it is, because there's a few of them. A is north 25 degrees west. For B, here we need to go, I don't even know how we express B as a compass bearing. I don't know if we'd say north 90 degrees east. I guess we could. North 90 degrees east. Because frankly, it's just due east, isn't it? When we say due east, it means sort of nothing else, just east. C is on the south side, so south, and it's not 53 degrees. It's how far away from south. Now, of course, 53 and this angle here will be complementary. That'll add up to 90 degrees. So this must be 37 degrees. So south, 37 degrees east. And D is going to be south 40 west. It's important, it's very important that you have a diagram when you're dealing with these questions. Now, another example here before we wrap up. Find the true bearing, so a three-figure bearing, of Y from Z. So from Z, here we go. From Z, we've got a north arrow moving in a clockwise direction till we get to Y. So that's fine. Of Y from Z, starting at Z, moving to Y, right, that's straightforward 62 degrees. 062 we'll put to make it a three-figure bearing. Now, the bearing of Y from X, that means we need to be at X. Here's my north. I want that angle there. Right, from north moving in a clockwise direction. Now, together we can see this is 180 degrees. There's 41 here, so I need the supplement of 41 degrees, which is 139 degrees. Now, of X from Y, here's Y. I need, right, I could draw an arrow here, from Y to X. I need this one here. We can see that's going to be, more than 270. But remember, we're just doing the back bearing of this one here. Okay? That we're going the opposite direction. I can't take 180 away from it, so I add 180 to it. And that gives me 319 degrees. Right, yeah. And that looks about right to our diagram there, right? We said more than 270, yeah. 319 degrees. They're our true bearings. Rightio, that's it for bearings and navigation. If I can stress this again, a good big diagram, and you always need a north arrow at the from location. Rightio, that's it for this one. I'll see you in the next video. I'll see you in class.